Tennessee's at-home learning series for math. Today's lesson is for all fifth graders out there, although all children are more than welcome to tune in. This lesson is the ninth in our series. My name is Miss Williamson, and I'm a fifth grade teacher in Tennessee schools. I'm so excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see our previous lessons, you can find them at the Tennessee Department of Education website, www.tn.gov/education. You can still tune in today if you haven't seen the other lessons, but it might be more fun if you watch the other ones first, as we'll be using things we learned from those lessons in today's lesson. Today we'll be learning about subtracting mixed numbers with unlike denominators. Before we get started, to fully participate, you will want a piece of paper, a pencil, and something to write on. I'll give you a moment to get your supplies ready. Okay, let's begin. Let's look at this situation. The first chapter in Henry's book is 5 2/3 pages long. The second chapter is 8 2/5 pages long. How much longer is the second chapter than the first chapter? What is this question asking us? How much longer is the second chapter than the first chapter? Well done. Does that mean that we need to add these numbers together or subtract them? Subtract, right. If we add them, then we'd find how long the chapters were all together, but that's not what we're being asked to find. So we need to subtract them. So on your paper, write down this equation, this expression. 8 2/5 minus 5 2/3. What are some methods that we have used to subtract fractions or mixed numbers? I'm hearing we use fraction bars, I'm hearing we've used number lines, and we've used equations. Well done. For this problem, let's start by using a fraction bar. Can you start by modeling 8 2/5? How many whole bars do you think we need? 8. Let's draw those 8 bars. Remember, we want to keep those as uniform as possible. So there's 1, 2, 3, 4, 5, 6, 7, 8. All right. So we have 8 bars to represent our whole number of, let me rewrite that equation, 8 2/5 minus 5 2/3. Okay, we have a whole number of 8 because we made 8 bars because our whole number is 8. Is that going to be enough? I hear somebody say, no, we have to have room for the 2/5 as well. Very good. 8 2/5 is more than 8, but smaller than 9. So we're going to need another bar. Now, what do I do on this last bar? Right, I need to cut it into fifths because our fraction is 2/5, and I need to shade in how many? 2. But don't forget, we also, I'm going to use yellow, I think. We also need to make sure we shade in our wholes. All right, and so we have represented 8 2/5. Now, we want to subtract 5 2/3. What does that 5 represent? Yes, the 5 represents whole bars. Can we go ahead and use the 5 to subtract 5 whole bars? We sure can. How do we model subtraction? We X it out. So let's do that. Let's take away 1, 2, 3, 4, 5. That leaves us with 1, 2, 3, and 2/5. Am I done? No, I'm not done. I still need to take away how much? I still need to take away 2/3. Very well done. And so what we notice is that this denominator is 5 and this denominator is 3. So do we have equal size pieces? No, we don't. And remember, in order to subtract or add, we need to have equal size pieces. So exactly how do we do that? Do you remember? I heard somebody say we can use the multiples of the number. Very well done. So let's find the multiples of our denominators. Our denominators are 5 and 3. So 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, 3 times 1, 3, 3 times 2, 6, 3 times 3, 9, 3 times 4, 12, 3 times 5, 15. What multiple do you notice that they have in common? Did you say 15? Let's circle it. So if we have 5 pieces and we need to get it to 15 pieces, what can I do to my fraction bar to get it into 15ths? That's right, we need to divide each fifth into equal pieces, and we need 3 equal pieces because 15 divided by 5 is 3. Or you may have said, what times 5 equals 15? Whatever way works best for you is fine. So let's do that. I'm going to zoom in a little so we can see that better. Each of my pieces now needs to be cut into 3. So let's do that. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. All right. So how many 15ths is 2/5? Did you say 2/5 equals 6/15? That is correct. Those two numbers are equivalent. Great. So now all we have to do is subtract 2/3. But 2/3 is not in 15ths. So we have to figure out how to get 2/3 into 15ths. So let's go ahead and draw a model for 2/3. Let's start again with our fraction bar. If I'm wanting to represent 2/3, I need to partition it into 3 sections and shade in 2 of them. Now we have to answer the question again. What can I do to thirds to make them 15ths? What times 3 equals 15? Shout it out at me. Did you say 5? So each section needs to be cut into what? 5. Let's do it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And remember, it's really good to check yourself. So let's look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Very good. So we could say 2/3 is equivalent to how many 15ths? Excellent work. That's right. 10 15ths. So now that we know I have our number in 15ths, are we able to take away 10 15ths? Let's look at the model that we have. Ooh, good job paying attention. You're right, we can't the way it is. I have 6 15ths and I need to take away 10 15ths. So what should I do? Good idea. Let's divide up one of our wholes into 15ths. Then I think we'll have enough pieces to subtract. Can you do that with me? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Excellent work. So let's see. How, once again, do I model subtraction? Yes, I put X's over it. So how many do I need to remove? I'm subtracting 2/3 or 10/15. So let's do that now. Ready? 1, 2, 3, 4, 5, 6/15. 7, 8, 9, 10, 11. Oops, I did one too many, so I'm going to mark that one out. I only needed to take away 10. So we need to be sure to count that. That's part of our answer. So let's do that. How many pieces are left? 2 wholes and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Did you get 2 and 11/15? Very good. Great work. Now, do you remember that we use a number line as well to find equivalent fractions and subtract them? Let's explore what this would look like on a number line when we're subtracting mixed numbers. Let's start with another problem. Let's start with 5 4/5 minus 1 9/10. 5 4/5 minus 1 9/10. Now let's start by drawing a number line. Look at the first fraction. Between what two whole numbers does 5 4/5 fall between? Right, between 5 and 6. So we need to be sure to include 5 and 6 in our number lines. But we also need to remember that we're subtracting. So what's going to happen to our number? It's going to get smaller. So we're going to have to label some behind the 5 as well. So let's do that. Let's start with a 3 and let's end with 6. Does your number line look like this? Now, what do we know about 5 4/5? Well, we do know that 5 4/5 comes between 5 and 6. So we know it's going to be somewhere over here. Yes, we also know that 5 4/5 needs to be, the whole needs to be cut into 5 pieces. How did we know that? Because our denominator was what? 5. Excellent. So let's do that. Between 5 and 6, let's put some tick marks to make it into fifths. 1, 2, 3, 4, 5. Excellent work. Excellent work. Now count with me. 5 1/5, 5 2/5, 5 3/5, 5 4/5. Very good. And so let's put our dot over 5 4/5. That's where we're starting, at 5 4/5. Excellent. Now we could label these. Do you want to? Okay, let's do it. Now let's leave some room. We're not going to do our whole number because we need to hold on to some room, but let's underneath it, let's know that this is 5 and this is 1/5, 2/5, 3/5, and 4/5. Well done. Now we need to subtract 1 9/10. It's easy enough to take away 1, but our graph is marked fifths, not tenths. How are we going to take away 9/10? What should we do? Of course, I heard somebody say, well, instead of fifths, let's cut them into tenths. That's a great idea. So how do we do that with the part that's already cut into fifths? Right, we can take fifths and say, what times 5 equals 10? Say it to me. What times 5 equals 10? 2. So each section needs to be cut into what? Into 2. So let's do that in between here. And so that means, let's label those. This would be 1/10, 2/10. Let me see if I can zoom in a little so it's easier to see. 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10. Fabulous work. Now, if we're going to subtract, do you think it's important to label the rest of our number line? I think that is important. And so let's go ahead and do it. Let's partition or cut. Let's take a moment to cut between 3 and 4 and 4 and 5 into tenths and label those. Kind of gets a little crowded there, but that's okay. We can see it. All right, now let's stop. When we want to subtract, I want to go backwards. I want to take away. So what I want to do is I want to start at 5 and 4/5 or 5 and 8/10. Very well said. So underneath this, I'm going to write the equivalent, 5 and 8/10. And now I want to take away a whole. 5 and 8/10, take away 1 would be where? Where would I jump back to? 4 and 8/10. So I'm going to make a hop to 4 and 8/10, and I've already subtracted 1. But I can't forget I got to subtract what? Excellent work. You're right. I need to take away the 9/10. So can you do that with me? Can you help me count back 9/10 to see where we are left? All right. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10. When I go back 9/10, so I've taken away 1 and 9/10, where did we end up? That's right, good job. We did end up at 3 and 9/10. So I could say that the difference is 3 and 9/10 because that's where we landed. Now, we just went through an example of subtracting using fraction bars, and we went through another example using subtracting using a number line. We can use either method to find equivalent fractions that have common denominators to help us subtract, even when we use mixed numbers. Did you notice that we still needed a common denominator even when we were working with the number line? We couldn't do it with fifths and tenths. We had to get equal parts. Otherwise, we would jump back and it wouldn't represent the right value. Let's try another problem. Kara's bathroom floor has an area of 3 2/3 square yards. She lays down a rug that has an area of 1 1/4 yards. What area of her floor is not covered by the rug? What information is this problem giving me? Yes, it's telling me two pieces of information. It's telling me the area of Kara's floor. That's the area of her floor. And it's telling me the area of the rug. The area of the rug. What's it asking me to find? Good catch. It wants me to find the section of the floor that is not covered. If I want to know the section of the floor that is not covered, am I going to add these numbers together or am I going to subtract these numbers? You are absolutely right. We're going to subtract them because we want to know the difference in the areas instead of how much in all. Very well said. All right, so make sure you write this problem down. Are you ready? 3 2/3 minus 1 1/4. Let's solve this one using a number line. Let's start by drawing our number line. In order to plot 3 2/3 on the number line, we need to know what whole numbers to include. So remember, we need to know what wholes does 3 2/3 come in between. Excellent. I heard somebody say it comes in between 3 and 4. 3 2/3 is bigger than 3, but smaller than 4. So we need to be sure to include 3 and 4 on our number line. Do I need to include other numbers other than 3 and 4? Yes, I do. I hear yes, I do. So which ones? How do we decide? Oh, yes, since we're subtracting, you're right. It would be important to have a couple of numbers behind or smaller than the 3. So let's do this. Let's start our number line with 1, and let's end our number line with 4. Make sure you leave some room because we're going to have to partition between it. So 1, 2, 3, 4. Does your number line look similar to mine? All right, so now we want to ask ourselves, where does 3 2/3 go? Well, to find out where it goes, I'm going to have to do what? I'm going to have to put some tick marks. How many spaces do we need between each hole? 3? Why do you say 3? Yes, because that's our denominator. So let's do that. Are you ready? Between every hole, let's do 3 tick marks. All right. So where on our number line is 3 2/3 going to go? Right. Let's place it right there. 3 2/3. Can you draw a little dot above that for me? Excellent. Good. Make sure your number line looks like mine. All right. Now, we're gonna want to subtract how much? 1 1/4. Can we do that? Are we ready to do that yet? No? Why not? Of course, you're right. We don't have fourths, we have thirds. So what do we need to do? Right, we need to find a common denominator so we can divide this number line into equal sized pieces so that we can subtract. And remember earlier, we practiced finding a common denominator by using multiples. Can you take a few moments and find the multiples? Will you list the multiples for 3 and 4 on your paper? Does your list look similar to mine? Great. Did you recognize that the 4 and 3 both share a multiple of, oops, I didn't mean to circle 4, I meant to circle 12. Both share a multiple of 12. So let's go ahead and change our thirds to 12s. How would I divide up each third to get 12? I heard cut it each piece into 4. How did you get that? Because 12 divided by 3 is 4, or what times 3 equals 12? Well done. So let's do that. Check your number line. It's always a good idea. Remember to check to make sure we have 12s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. So we could say our point, 3 2/3, is also equivalent to how many 12s? 3 8 12ths. Fabulous. Now we have to find out how many 12ths is equivalent in 1/4. How do you think we could do that? Well, let's do it a little bit different than we did last time. Let's draw us another number line. Draw you another number line directly below the one we've already done. And this number line, we're going to just do between 1 and 2. Because we're going to start by modeling 1 1/4. If I want to model 1 1/4, what am I going to do in between 1 and 2? You're right, I'm going to partition or cut it into 4 equal pieces because my denominator is 4. So let's do that. Can you put a dot where 1 1/4 is? Did you put your dot there? 1 and 1 out of 4. Now remember, we said our common denominator was going to be 12. So we got to ask ourselves the question again. What can I do this time to force to make them 12s? So 12 divided by 4 is, yes, 3. So each fourth needs to be cut how many times? 3. So what can we say? 1 and 1/4 is equivalent to how many 12ths? 1 12, 2 12, 3 12. So 1 and 1/4 is equal to 1 and 3 12. Excellent work. Now, looking at our first number line, we will need to take away 1 and 3 12 from 3 and 8 12. What do you think we should do first? Okay, I heard somebody say they think the rest of our graph needs to be cut into 12ths. So let's do that. Remember, between each third, we're going to make 4 equal pieces to get 12ths. Can you do that for me? Okay, so now we can go ahead and subtract 1 whole. Are you ready? Let's start at 3 and 2/3 or 3 and 8 12ths, and I want to take away 12 12ths or a whole. So let's see, we need to get to 2 and 8 12ths. It would probably be easier if we had these labeled. But let's count. 1 2 3 4 5 6 7 8. So this is going to be our 8 12ths. So let's go ahead. We're going to hop back minus 1. But I still need to take away how many pieces? Yes, I need to take away 3 12ths. So can you do that with me? 1 12th, 2 12th, 3 12ths. And this is where we end up. And so now to solve completely, we need to find out where we ended up. So we have 2 and 1 12th, 2 12ths, 3 12ths, 4 12ths, 5 12ths. So we could say the answer to the problem is that Kara's rug did not cover 2 and 5 12ths of the floor. Great work, everyone. You guys did some great work today. You worked very hard. We reviewed subtracting mixed numbers with unlike denominators. I hope you're seeing some connections between subtracting mixed numbers and adding mixed numbers with unlike denominators. I'm so proud of your work. After the video, you will have some problems to practice on your own. I will show you the independent practice problems now, or you can find them in the student practice for this lesson posted on our website, www.tn.gov/education. I know you will, so remember to do your very best. I have so enjoyed being with you today, reviewing subtracting mixed numbers. Thank you so much for inviting me into your home, and I look forward to seeing you at our next lesson in the Tennessee's at Home Learning Series. Bye.